In this video, let's explore TypeScript's advanced types. In TypeScript, under basic data types, we have covered built-in as well as user-defined data types. Now, let's understand advanced types. Advanced type refer to a set of features that enable us to create more complex and flexible type definitions. So first, we will see the intersection types. An intersection type combines multiple types into one, which means it creates a new type by combining multiple existing types, and the new type has all features of the existing types. And to combine types, we use the ampersand symbol. Like here, you can see the example type AB equals to type A and type B. It means type AB will have all properties from both type A and type B. Now, let's understand this intersection type with a practical example. So here, inside Visual Studio Code, I'll create a new file with name advanced type.ts. And here you can see the advanced types.js file has been generated automatically because I have compiled this project in watch mode. So I'll just increase the font. Okay. So we have already covered one concept in TypeScript called as type analysis. And what is the purpose of type analysis? They allow us to create new names for existing types. Like here, we have a string type, but we want to assign a custom name to it. Then we can make use of type analyze. Like here, I can assign a new name to this type string with type keyword. Like this. So now, instead of string, I can assign a data type as a name. Like if I create a new variable named first name, and now I can assign the alias name instead of string type. Like this. Okay, here I need to declare this variable with letter var keyword. Okay, so this is how we can use type alias with variable in TypeScript. So similarly, I can define a type alias with name personal for an object that has two properties, name and age. So here, name of type string and age of type number. And now I'll create a new object with name person. Let person equals to, I'll define the properties name and age as a key value pair. So name is Vivek, comma, age is 25. Now to this person object, I want to assign the type personal. And this personal is a type which is our previously defined type alias. Okay. Now the intersection types means it creates a new type by combining multiple existing types. And the new type has all features of the existing types. Like we have seen the example in the PPT, type AB equals to type A and type B. Okay, so we need to use this ampersand symbol to merge the types. But before that, hope you remember the union type uses the pipe operator like this, and that defines the variable that can hold a value of either type A or type B. Okay, so here this is the example of intersection type and this is the example of union type. But in this statement, this type AB variable can hold the value of either type A or type B. But in the intersection example, type AB will have all properties from both type A and type B. This is the key difference between union and intersection type. Or we can say union types work like OR logic, where at least one condition must be true. In contrast, intersection types work like AND logic, requiring both conditions to be true. Okay, so let's understand this intersection type with this person object. So here, let me create one more type with name contact. So here, I'll edit this personal name to contact, and here instead of name I'll write email, and the second property is mobile number of type number. Now we have two type aliases. One is personal and one is contact. And I want to assign both type aliases to the person object. And to achieve this, I'll utilize an intersection type. Okay. So how do we do that? So here I'll create a new type alias named student, and here I'll assign it the intersection of personal and contact. So here I'll write personal ampersand symbol and contact. Duplicate identifier. Okay. So here I'll use small s. Now what I'll do, instead of this personal, I can assign this student type to this person object. Okay. Now since the person object is of type student, so it will inherit all the properties from both personal as well as contact type. And what are the properties of personal and contact? Personal type is having two properties, name and age, and contact type is having two properties, email and mobile. And we have already defined two properties, name and age, which comes under personal type. Now we need to define the properties which comes under contact type. Okay. So here I'll add email, and the value of email is vivek@gmail.com. And last property is mobile equals to. Okay. Now we have added all the properties from both personal and contact type as a key value pairs. And here note that the order of type doesn't matter when combining them. You can define contact properties before personal properties and still it will work. Okay. So this example demonstrated intersection types with type aliases, but they can also be applied to interfaces. And we have already seen why we need interface in TypeScript and how to use the interface. So here we will replace the type keyword with interface and creating the alias name as an interface name. The only other change needed is removing the equal to symbol. That's it. So similarly here also I'll replace the type keyword with interface keyword and I'll remove the equal to symbol. And in this case also the intersection type is working as expected. And one more thing here, if both the interface or type alias have a same property with same name and data type, you only need to define that property once in the object. Like if you have the email property inside personal interface as well, like email of type string, then you don't need to define the email twice in the object, because this email property is available in both interfaces with same name and same data type. Okay, so this is all about intersection type, and intersection type combines two or more types to create a new type that has all properties of the existing types. Now let's understand the second type, that is type guards. Basically, type guards are used to narrow down the type of a variable within a specific block of code, and it shows how you should deal with data types while writing the code. So let's understand type guards with type of and instance of operator. So here I'll comment out all this code. Here I'll write down the comment intersection type. And now let's write the example of type guards. And here first we'll see the type guard example with type of operator, and then we will see with instance of operator. Okay, so under type of operator, I'll create one function with name test, and here I'll pass one parameter with name x of type string as well as number, and here I'll use type symbol, and this is called as union type. So in this scenario, if we assume this x is a string and we want to use two uppercase function with it, like x dot to uppercase semicolon. But here we are getting an error. Property to uppercase does not exist on type string or number. So to resolve this error, we need to add additional validations to narrow down the type of X, assuming our code is more precise. Okay, so here I'll write if condition, and in condition I'll use type of operator like type of X equals to string. Then I'll move this statement inside if condition. Okay, now you can see error has gone. I'll add the second condition, that is type of X equals to number, and here I'll use X dot toFixed method without an error. Okay, and here instead of this else if block, you can also write this X dot toFixed method inside else block. Okay, so this is how we can make use of type guard in TypeScript. Now let's explore another type guard example, that is instance of type guard. So here I'll declare one class with name parent and body of the class. And after that I'll declare one more class with name child, and this child class wants to extend the parent class. And inside this child class I'll write one method with name getData, and inside this method I'll log one message. This is child class method. Okay, now after this I'll create one function here with name info, and here I'll pass one parameter p, and I'll assign the type of this parameter p is parent, this parent class. Okay, now we have written the code like child class is extending parent class, which means now a child class can access all the members from parent class. So once I create an instance of a child class, with the help of object preference variable, we can access the properties, or we can access the all members from parent class. So now inside this function I want to call this getData method. So here what I'll do, I'll just write p dot getData. That's it. But here you can see we are getting an error. Property getData does not exist on type parent. So in order to resolve this error, we can make use of instance of operator. So here I'll add one if condition, and the condition is p is instance of child. Then I'll invoke this getData method, and now you can see error has gone. Okay, so this is how we can make use of type of and instance of operators to implement type guards in the conditional block. And I repeat, type guards are a powerful feature in TypeScript that allow you to narrow down the type of variable within a specific block of code, and they provide a way to refine the type of a value based on certain conditions, making your code more expressive, maintainable, and type safe. Okay, now let's understand the third type, that is type assertion. We have already covered type assertions while learning basic data types in TypeScript. But since the type assertion comes under advanced type, we will quickly understand this concept with a practical example. So the type assertion is a way to manually specify a variable's type in TypeScript, overriding any incorrect assumptions made by the compiler. And the TypeScript provides two ways to do type assertion. First is using angular bracket, and second is using as keyword. Let's understand this with practical example. So here, this is the example of type assertion. Here I'll create one variable with name sample, and I'll assign a string value, this TypeScript. Okay, so this sample is a variable name of type any, and I have assigned the value TypeScript to this sample variable. Now let's create another variable with name language, and now I want to assign the same value to the language variable as a sample, that is TypeScript. So in this case I can use type assertion, inform the compiler about the correct data type of the value. And as I said, TypeScript support two types of type assertions. First is using angular bracket. So here I'll add string inside angular bracket, and then I'll use this variable name sample. So in this case, I have assigned the same TypeScript value to this language variable using angular bracket. So here, if I log this language with type of operator, and if I run this file, ls, and I'll run this file with command node space advanced type as advanced types. And here you can see output string, because this value is a type of string. Okay. Now let's assign the same value using as keyword. So here, instead of this, we can use as keyword sample as and type string. That's it. So the type assertion allows you to set the type of value and tell the compiler not to infer it. Okay. So we have now covered both the theoretical and practical aspects of intersections, type guards, and type assertions. So that's all for advanced types in TypeScript. Thank you for watching, and we will see you in the next video. Bye bye.